Do bunches over there. Surfing Cat has pencils. Oh. Like your shoes too expensive to walk in? All right. So this is using those perfect square trinomials we were talking about a bunch the other day. Just kind of go back and practice through them where it meets that special pattern that we used. And I gotta lock the screen out. There we go. When we have our something squared at the beginning, plus our 2 times the front times the back, plus our b squared. And that's what we can put into our perfect square form of the a plus b squared, that guy. So we're trying to figure out what this chunk would be on these guys to make it look like that. So it needs to follow this pattern with what I've already got. So I know the a piece, this guy's going to be the x squared. The middle piece needs to be made up of 2 times the front times the back, our back piece here. And that's what makes our back piece that gets squared. So what does this b piece need to be? That was usually what we did as question mark. I'm going to switch it back to question mark. Sorry, my brain is tired. I was here until 7:30 last night. Yeah, question mark's going to need to be 11. So what is c going to be? 11 squared. So our c equals what? 11 squared, which is 121. That's what I was waiting for. So if this was x squared plus 22x plus 121, then we could write this in that perfect square form where I have my what's in the front. Thank you. I was going to be like, you're going to be sad to miss the show today if you were here. Plus question mark, which is our 11 squared. So we can write this in our perfect square form. That's what the perfect square form is. Same deal on the right-hand one. We're looking to find what that piece would need to be a perfect square. So the front piece is my x squared, so I know this guy's just going to be an x. C gets made up from something, squared. And the middle needs to be 2 times the front times the, So what is question mark going to be on this one? 6. Yeah. So our question mark is going to equal 6. So what does C equal? 36. So when we put this in our perfect square form, what's it going to be? What's inside my parentheses? X minus 6. Good catch on that. We didn't mention that at all. This sign always is whatever this first sign is in the equation. We hadn't mentioned that yet today. But minus 6 squared. Okay, so those will pop back up every now and again. That is not a tie-in to what we're about to do. That's just a review. Sometimes we tie things in. Sometimes we just review stuff. That was not a tie-in. Because today we're going to finish out working with our quadratic formula, which means you get to get the whole thing. I'm going to warn you now, it's a little long, but you're going to want to write the whole thing down carefully because it needs to be accurate in order to be able to use it. Okay? So, it's this guy down here. And if you're going to wind up in pre-cal, You're going to need to have that memorized. Like, you're going to need to know it.
I'm going to say you.
It's honestly not as bad as it looks. We already know most of these things. We just haven't talked about them combined together. And I'll point out the pieces once we get into working with stuff a little bit. There are many, 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 many beautiful songs on YouTube that work as like mnemonic devices to memorize this. Like, there's Pop Goes the Weasel, which is the classic one. There's some to Dre. There are some to, I believe, Katy Perry songs. The one to Superman is my favorite. It's called Crank That Quadratic. Yup. They are epic levels of chaos. Like, we're talking Chef Kiss levels of so bad that they're, I'm not going to say good, but so bad that they're so bad that they're entertaining.
Yeah.
So if you ever like run out of things to search on YouTube, the quadratic formula songs are an chaotic level of chaos. They're epic. But we don't need to memorize this. I do give you the formula on the test. Like, it's going to be printed there. On the homework, it's printed on there. Like, you don't have to memorize it for us. We're going to use it a bunch of times, so you might wind up doing it. But we just need to know how to use it. And so there are pieces in here that we know. I'm going to write a few little formulas down for us that are built into this thing. Our very first formula we used for this chapter, our axis of symmetry, our minus b over 2a. Well, up here we've got a minus b over 2a. Snap, that's built right in there. That's our axis of symmetry. That's this guy. It's in here. Oop, there we go. The piece we used yesterday, b squared minus 4ac. That's that guy. That's our discriminant. The guy under the square root. So b squared minus 4ac is the discriminant. So when we're doing this quadratic formula, we're going to take our opposite of b, and then we have to go plus or minus, because we've got a square root in an equation, the square root of our discriminant over 2a. And that gives us our solutions. Like, it straight up just spits them out, no other solving, no other things we have to do. That gives us our roots, that gives us our solutions, it gives us our zeros, it gives us our x-intercepts. That gives us, end of story, the answers. And this is the one technique that works for absolutely every single quadratic ever. No type of factoring needed, no type of completing the square. No, it works for imaginary roots, it works for real roots, it works for irrational roots. It works for literally everything. It's just the most intimidating to look at. It works every single time, guaranteed 100%. It works. Factoring does not work for every type of question. Completing the square can sometimes be ridiculously challenging. Quadratic formula works every single time. Every single time. It's just scary looking. So the same pieces we used yesterday are A, B, and C. Thank you. Our same pieces we used yesterday for A, B, and C are what we use to fill this in. We're going to do it in little chunks, because if I just try and take this whole thing and type it in the calculator, odds are I'm going to have something wrong. It's just too many pieces, and they physically don't fit on a screen. So we're going to do it in chunks, but it's the same vibe. So we're just going to like hop straight into it. So I still have our quadratic formula up there on the top right, so we're going to be able to see it, look at it, and find our pieces. But we've got right here is our first quadratic. So the first thing I want to do is find our A, B, and C. Ooh, close.
1.
A is 1. It's the number in front of our x squared.
B is 4.
B is 4.
C is -17.
Gorgeous. There should never, ever, ever be letters inside of these values. Never, ever. When we fill in this guy, there should never, ever be letters left. Never letters inside. The x is over here on the completely other side from all numbers. No x's in this thing ever, 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 ever. So what you could do is hop straight in and just start plugging and chugging and go the way we're going to go. But honestly, it gets a little overwhelming. So what we're going to do first is we're going to do our discriminant, just like we did yesterday. I'm going to take this guy under the square root, my b squared minus 4ac, and we're going to do that. We're going to figure out what kind and how many roots, that stuff we did yesterday. So I'm going to just put it over here, my b squared minus 4ac. So my b is my 4. Minus 4 times a, which is 1, times c, which is -17. Oh, I forgot the square root on my b squared. Whoops. There we go. 4 squared minus 4 times 1 times -17. So let's simplify this, just like we did yesterday. My 4 squared gives us 16. My minus 4 times 1 times -17. This is going to give me a plus 68. And 16 plus 68. I got 84. Okay, cool. Just double check. It's early, so I like to use y'all as double check sometimes. Okay, so that's our discriminant. We use that part first. So then what we're going to do is we're going to see that this answer is the value of this chunk, which is the whole guy underneath the square root. Yes, 100%. That's what we're going to do. So before I do that, though, I just want to take a peek here. We're going to use what we did yesterday. What kind of roots are we going to have here? Are we going to have 2 real, 1 real, or imaginary? 2 real. I was going to say, they're not going to be pretty, but they're going to be real. So what we're going to do is we're going to take our quadratic formula. Our x equals the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. Ugh, it's a lot. We're going to take our discriminant, that chunk under the radical, and we're going to substitute that in. So we're going to have, oops, that's not a pen. There we go. Our x equals, and I'm going to leave the letters in there for the most part for a lot of things here. My minus b plus or minus the square root of, but we did the b squared minus 4ac, and that's where we got our 84. So I'm substituting the value we got in for that chunk. And we're over to A. So I'm simplifying that piece first before we go too big, because it can just get super gross in the calculator. So now we're going to plug in the rest of our pieces. Substitute those in. So I've got my x equals the opposite of b. My b is 4. Plus or minus the square root of 84 over 2 times 1. We can simplify this a little bit because I've got the opposite of 4. Well, that's -4. Plus or minus the square root of 84 over 2. We could absolutely simplify the square root of 84. We could simplify that by hand if we wanted to, or we could type just that into the calculator. We're going to want to simplify the whole dang thing anyway. So let's just type the dang thing into the calculator and let the calculator do the work for us. It's a tool at our disposal. The yellow calculator is pretty awesome. Opening up my software. There we go. All right. So when we're doing these, just be super duper careful. I'm going to hit the fraction button, second column, third button down. Looks like that. And I'm going to put in my -4 plus. To get our square root, we hit the green button, and then we hit the square button. That'll give us our square root of 84. Hit the down button to get to our denominator, and we've got our 2. The calculator can simplify the radicals. The calculator can simplify the fractions. It'll do it for us. So one of our answers is the square root of 21 minus 2. So we said we were going to have 2 real roots. That's one of them. Square root of 21 minus 2. Make sure it's really clear that your minus 2 is not inside the square root. It is not the square root of 19. Those are different things. What is that as a decimal? Because if I was trying to sketch that, I would have no idea where that is.
2.582.
Yeah. To get it to switch to the decimal, that's when we hit the 2 arrows just above the enter key. We just got to practice doing that. Right there. And we've got 2.58. I'd round that to 3 since we've got the 5 after there. 2.583 or 2.58. Depends on how many decimal places we ask for. Let's go with 3 for now. So 2.583. Just be careful on our rounding. We're going to do the same thing for the minus sign because we had this plus or minus, which means I need to do both plus and minus. So our second solution is going to have a pen. There we go. I'm going to have my fraction, and we're going to put our -4, minus, there we go, the square root of 84 over 2.
It's the same thing, just with a negative.
It's very, very similar. It's negative square root of 21 minus 2. They're very similar, and they will always be very similar. This is negative square root of 21 minus 2. What is that as a decimal? Watch our rounding. Because we want to 3 decimal places. If this is 5 or bigger, it pushes that one up.
It's the same 0.583.
Yes.
It's just the 2 turns into -6.
Yep. The decimals won't always be exactly the same, so it is important to check and be careful of our rounding. A lot of times they'll be really close, but so when they're not the same, they're going to be real different. But we want to be able to write it in both forms. This one over here, this is called our simplified radical form. And this is our approximate decimal. Simplified radical form is technically more accurate because it is not rounded. This is simplified radical form. This is called approximate decimal. You will need to give both on some of these questions. Sometimes we'll ask you for radical form, sometimes we'll ask you for decimal form, sometimes we'll ask you for both. So it's really scary looking, but I don't feel like it's not too bad. What's up?
So in the homework or in the test, we have to write the radical form, the simplified radical form on the decimal plate?
Only if we ask you for both. You have to put both. Yeah. And I'll make sure it's really clear on the test and on the review which one I'm looking for. When in doubt, leave it as radical form, because radical form is technically more accurate. But it's just that I have no idea what square root of 21 minus 2 is. I don't know where that is without typing it in the calculator. Okay, so it's really scary looking and it's really big, but I feel like it's not super awful once we get into it. It's not super awful. We're going to practice this again, because of course we are.
What do you expect?
What do you expect? I'm never just going to give you guys one problem of something.
As much as we want.
I know. Because I'm horribly, terribly cruel. Wahahaha. All right. So, same vibe here. We're going to start with finding our A, B, and C. We're going to simplify stuff. Do what we can. So, what is our A? 5. What is our B?
8.
Gorgeous. And what's our C? 11. We're going to start with the discriminant. That's the guy under the radical. That's the first piece we want to do. So our B squared minus 4AC. You guys got a question over there? You good? Okay. It looks really scary looking at it, but it's not bad. It's substituting in, but everyone gets really scared looking at it. I know. You do. You do. And I even give you the formula. You don't even have to memorize it. You just need to know what to do.
It's a lot.
It's a lot. I get it. It's a lot, and it's busy. All right, so my 8 squared, that gives me a 64. My 4 times 5 times 11. We get minus 220. So what is the value of our discriminant? So what kind of roots are we going to have? Imaginary. We're going to wind up with 2 complex roots, or 2 imaginary roots. So now we're going to have to be super careful, because calculators are really, really bad at doing imaginary numbers. It will give us an error. So we're going to have to be super careful and take care of the I part ourselves. So now we're going to fill in our quadratic formula with the piece that we have. So we're going to take our opposite of B. So I'm going to go ahead and fill that part in now. Plus or minus the square root of our discriminant, our negative 156 over 2 times our A, which is 5. So we're going to simplify this a little bit, because some of these things are icky. So the opposite of 8, that's the same thing as negative 8. What could we do about this square root of negative 156? What do we notice there?
Well,
I. The negative is what makes it an I. So we know there's going to be an I in here somewhere. And then it would leave me with just the 156 under here. If I take the I out, That makes it something that the calculator can deal with.
And then once we put the answer with
The I stays by the radical. So as long as we put the I back with the radical, we can still use the calculator to simplify. So this is going to be over, what's my denominator on this piece? 10. So again, there are ways to do this by hand. You absolutely can. We would simplify our radical and we'd try and simplify our coefficients. We can also type this into the calculator and just be super duper aware that this I stays with the radical piece. So let's see what that's going to look like. Whenever we have complex roots, we will not put them in decimal form, ever. Complex roots only go in imaginary form, or in radical form. So let's get it down to as simplified as we can get. So I'm going to do my fraction with my -8. Let's go plus the square root. And we're going to skip the negative. We just know that there's going to be an I in front of that radical. Over our 2 times 5, which was 10. And it's icky, but this is our simplified radical form.
You gotta put an I in front of 39.
Yes.
Wait, why
Was because the calculator likes to make choices. If you put it as -4 plus square root of 39, that's totally fine.
Okay.
Like, it genuinely doesn't matter. I don't like it either, but it's the way the calculator does it, so I'm going to take it. So we just got to remember that we removed the I from this spot when we typed it in, so we got to put the I back in front of the radical when we write our answer.
Okay.
So we can use the calculator to simplify this, and it's going to give us a wrong pen. There we go. The square root of 39, or sorry, I, we can't forget the I, minus 4 over 5. And that's our simplified form. If you want to put it as 2 separate fractions, you can. It would be square root of 39 over 5 minus 4 over 5.
Do we have to do it the other way?
We're going to do it with a plus 2. Yep.
Yeah.
Type it in the calculator. Which piece is going to have a different sign? Mm-hmm. Yep. So it's going to be our minus I square root of 39 minus 4. We got to put the I back in here. Because what we're doing when we're doing our plus or minus is we're literally taking this plus or minus. We're doing plus this or minus this. So it's always going to be our radical piece that changes sign, which is why it's annoying that they put it in the front. Ew. But whatevs. So complex roots only come in simplified radical form. We cannot make this decimal. Without the I, you can switch it to decimal. But when there's an I in there, we cannot. So these are our answers here. So it works for our complex roots. We're going to do one more, naturally. We'll just do 3. And it's everybody's mostest favorite. Yay! This is when we really kind of have to have the quadratic formula. Because, looky here, we've got super ugly gross numbers in here. I've got minus 16 and 124.4 inside here. Definitely cannot factor this. Do not want to complete that square. Ew. It's disgusting. But we can use the quadratic formula. So, context regarded, I can use quadratic formula to find my solutions. This is another catapult, because we love to do a catapult problem in quadratics because catapults are fun. And we're looking for the solutions. We're looking for when it hits the ground, basically. That's what the solution's going to give us, when our height is 0, because what they've done is they've substituted in 0 for the height. So when we solve this to figure out what t is, which is the same thing as what x would normally be, that's going to give us the time after it lands. So our pen is wrong. We're going to use our quadratic formula for this, but that means I need to know my A, my B, and my C. What is my A? Negative 16. What is my B? 124.4. Gross. Nope. But we're using calculators, so we can do this. What's my C? 42. The meaning of the life, universe, and everything. All right, so we're going to do our discriminant first. Our b squared minus 4ac. That guy first. So we're going to take our 124.4 and square it. Minus 4 times negative 16 times 42. What do we get as the value for our discriminant? 0.36. It's gross, but it's a thing. That's the value of our discriminant. That's the under the square root thing. So are we going to have one real root, two real roots, or complex roots? Two real roots. So let's use our quadratic formula. I'm going to write it as a t equals because our equation uses t, but if you write it as x equals 100%, I get what you mean. That's when we're going to have our opposite of b, and our b is that 124.4, and we're going to do our plus and minus the square root of our discriminant, which is gross, 18163.36, over 2 times our a, negative 16. Gross. We could simplify it if we wanted to, but honestly, I'm going to go, let's just let the calculator do the work on this one. So, in our fraction, we're going to put in our negative 124.4 plus the square root, I got to zoom out and get my square root of 18163.36 over 2 times negative 16. I don't even have to think it. I can type it in just like that. Even the calculator goes, gross. It doesn't want to simplify it either. Valid. So we get negative 0.324 as one of our answers. Negative 0.324. Then we need the other one. And you could, 100%, type the whole darn thing in again. But what is the only change that is made between the one we just did and the one we want to do? A minus sign. So what I'm going to do is I'm going to hit up, up, enter. It puts it back in the active line. And I can just go back, 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 back. Many, many times. Until I get my little blinky dot over the plus, and I can then hit, I don't want that to be a plus. I want that to be a minus. Thank you. And you don't have to type the whole thing in again. You can, absolutely valid, type the whole thing in again, or you can go up, up, enter, and just hit back until we change the thing we need to change. So, save you a little work there, a little shortcut. We love a calculator shortcut. Then we don't have to type the whole thing in again. So then we get 8.099. So we've got our two solutions. So now let's answer the questions that were asked, which is, when did it land? They launched a pumpkin. How do we know that that's the answer we want? If it lands at negative 0.3 seconds, that means I'm ready to launch my catapult. Oh, look, it already landed. It rolled off the back. That's what that means. It lands before it launched. Before. It can't land before it launched. I need it to launch, then land. We can't go back in time. That negative 0.32 means my pumpkin traveled backwards in time. So if we have story problems and we're looking at context, that's what that means. We cannot go back in time. Cannot time travel. Yet. But as of right now, not a valid answer because pumpkins cannot time travel as far as we are aware. Maybe pumpkins have this whole other discourse going on, but as far as we are aware, pumpkins cannot time travel off catapults. Okay? So that's all that is. So when we're looking at things in context, just make sure we get a logical answer. Apply a little logic to the thinking. We're not going to have negative 4 seconds of time. Okay? So we can do ucky things with quadratic formula. And that is end for today. We've got about 4 minutes until announcements. Yeah, let me pass.